The determinant of a square matrix is a number that we assign to the matrix. And later on, we're going to see that this number carries geometric information. But in these videos, we're just going to figure out how to calculate these. First in the 2x2 case, and then in the 3x3 case. And it's going to turn out that we always do it in the same way. First off, some notation. When we write a matrix, we usually draw it with brackets or parentheses around it. But to make it easier to denote finding this number, the determinant, we're going to get rid of those brackets or parentheses and just use straight bars. The way we find this number for a 2x2 matrix is we multiply together the elements on the diagonal. We're going to multiply the elements that are off of the diagonal, and we'll subtract the two products. So let's work out a few examples. In this first example, we've got 3 times 3 minus 1 times negative 2. Okay. Or 9 minus negative 2. This is 11. In this next example, we get 0 times 0 minus 1 times 1, or negative 1. And in this third example, we have 4 times 15 minus 6 times 10, which is 60 minus 60, or 0. So we're going to spend some time later on talking about when matrices have determinant equal to 0 and what the consequences are. But we can see this more naturally by noticing that the second column is just a multiple of the first column. So if you think about calculating AD minus BC, we're going to see that that 0 comes out. Okay, next we're going to build up to finding the determinant of a 3x3 matrix. Okay, a quick review of some vocabulary. So the minor of an element in a matrix is the determinant of the smaller matrix you get when you delete the row and column containing your element. Okay, so for example, if we're looking at the element 4, a minor of 4 is going to be the determinant of the matrix we get when we delete. So I'm shading it, but we're deleting the row and column containing 4. Okay, so this is going to be the determinant of what's left, the matrix 2, 3, 8, 9. Which ends up being equal to 18 minus 24, or negative 6. Let's do this again. Let's find the minor of 2. We're going to delete the row and column containing 2 and calculate the determinant of the matrix that's left over. So we have 4, 6, 7, 9 is the matrix that's left over, and its determinant is 36 minus 42, which is, again, negative 6. The cofactor, Cij, of an element at position ij is going to be its minor multiplied by either +1 or -1. And we decide based on, we look at -1 to the I plus j. So this is either +1, so we're going to write a plus sign, or -1. Okay, so let's take a look at an example. We're going to calculate C12. This is the cofactor of this element. So it's in the first row, second column. So according to this formula, we're going to take -1 to the I plus j and multiply it by the minor of this element. Okay. Remember, we get the minor by deleting the row and column containing 2. This produces a smaller matrix, 4, 6, 7, 9. And we're going to find the determinant of it. The determinant of that matrix is going to be called the minor. Okay. This produces the element -1 cubed, which is -1 times 4 times 9 minus 6 times 7. Okay, so this is -1 times -6, or 6, is the cofactor of this element C2, C12. Okay. Another way that we can remember what a cofactor is the sign that we need to apply in front of it is by thinking about building the signs ahead of time. So notice that these signs are just based on I and j. It doesn't matter what the values in the matrix are. So if we start out with I equals 1 and j equals 1, we have -1 to the 2, which is 1. So rather than writing 1, -1, 1, -1, I'm going to just write pluses and minuses. So this is going to be plus. If I move left or right by 1 in this matrix, that will increase one of these indices. So we go from having an even power to an odd power. So they're going to be negatives. And then if we do it again, it'll be positive. So each time we change either a row or column, we're going to flip our signs. And the way that we can use this then is, let's go back and do this calculation again. If we've got C12, okay, we find this element 2. We find the same spot in our checkerboard, and it tells me multiply by the negative. We want to negate our minor. So we're going to do -1 times this 4, 6, 7, the determinant of the matrix 4, 6, 7, 9. Okay, so this is -1 times -6 is 6. Let's try one more example of this. It's a little silly. We're going to calculate the cofactor of the element 3, 1. Okay, so we find this element 3, 1, that's the element 7. What I'm going to do is find the minor of 7, and I'm going to multiply it by a +1. So I've got plus the minor of 7. Remember, we calculate this minor by crossing out the row and column containing 7, and this leaves us with the matrix 2, 3, 5, 6, whose determinant we're going to find. Okay, so we get plus 12 minus 15 is -3. All right, this is the cofactor. To find the determinant of a 3 by 3 matrix, we're going to do what's called a cofactor expansion. And what that means is that we're going to choose any row or column, and then we're going to multiply each element in the row or column by its cofactor, and then we'll add them all up. So for example, in this first example, I'm going to take the first row, I'm going to go through this first row, and I'm going to multiply A by its cofactor, plus B by its cofactor, plus C times its cofactor. And these are written out to the right here. Okay. In this second example, we're going to look at the second column of the matrix and expand in this column. So we're going to do B times its cofactor, which is first row, second column, plus E times its cofactor, plus H times its cofactor. And the amazing thing is that no matter which of the rows or columns we choose, we're going to get the same answer. Let's try this out. We're going to find the determinant of this 3 by 3 matrix. Now it doesn't matter for getting the answer what row or column we choose to expand in, but we will find that our arithmetic is simplified if we choose a row or column containing zeros. The more zeros, the better. So it doesn't really matter. I'm just going to use this third column because we've got a 0 in it. So let's try this expansion. We're going to do -3 times the cofactor of -3, which is C13, plus -1 times its cofactor, which is C23, plus 0 times its cofactor, which is C33. And here we can see why having these zeros is helpful. It means that we don't need to find this because we know the result is going to be 0 when we multiply it by 0. So it won't affect our determinant. Okay, now let's find these cofactors. Remember that we build a checkerboard pattern. I've got plus, minus, plus, minus, plus, minus, plus. Okay, we build our checkerboard pattern, and we will pull either a +1 or a -1 from this board. Okay, so first off, we've got -3 times +1, and now we're going to multiply by the determinant of the matrix left over when we crossed out the row and column containing -3. So this is -3, 3, -4, 3. Next up, we've got this element, -1. So we have -1 times, from the checkerboard pattern, we've got a -1 that we need to multiply in. And then we're going to find the determinant of the matrix that we get where we cross out the row and column containing this element. And so this is the matrix 1, -4, -4, 3. All right, a little bit of arithmetic now. We've got -3 times -9 minus -12 plus 1 times 3 minus 16. We want to be really careful with these signs. It's easy to make a mistake. So we have -3 times -9 plus 12 is 3. And then we have 3 minus 16 is -12. -13 okay. All right, and now we've got -9 minus 13, or -22 as our determinant, and we're all done. We're going to find the determinant of this matrix. So first up, I'm going to look to see if there are any rows or columns containing zeros. So we've got this final row that has 2 zeros in it, so this is definitely the easiest one to expand in. So this is going to be equal to 0 times C31 plus 2 times C32 plus 0 times C33. Okay, so there's only one cofactor that we need to find. Okay, we put in our checkerboard, plus, minus, plus, minus. So this is going to be 2 times -1 times the determinant of the matrix that we get when we cross out the row and column containing 2. So this is the matrix 1, negative 3, 5, negative 1. Okay, so this is negative 2 times negative 1 minus negative 15. Again, careful with those signs. Negative 2 times 14 gives us negative 28 as our determinant. Sometimes there's just nothing to be done. There are no rows with zeros in them. So we just need to buckle down, choose a row or column, and try expanding. So in this example, let's expand across the first row. So sometimes our matrices will store functions in. So we calculate 1 minus x times c11 plus negative 4 times c12 plus negative 3 times c13. Okay. And let's draw ourselves a checkerboard. We've got plus, minus, plus across our first row. Okay, so here we get 1 minus x times plus 1 from our checkerboard. And then we're going to calculate the determinant of when we throw out the row and column containing 1 minus x. This gives us the determinant of 3 minus x, negative 1, 3, and 1 minus x. All right, then we've got negative 4 times, we get a negative 1 from our chessboard, our checkerboard. We're going to erase the row and column containing negative 4, leaving us with the matrix negative 3, negative 1, negative 4, 1 minus x. Okay. And finally, we've got negative 3 times plus 1 from our checkerboard times the determinant of the matrix that we get by deleting the row and column containing negative 3. And this gives us the matrix negative 3, 3 minus x, negative 4, 3. Okay. So in total, we've got 1 minus x times 3 minus x times 1 minus x plus 3 plus 4 times negative 3 times 1 minus x minus 4 minus 3 times negative 9 plus 4 times 3 minus x. We could simplify this down a little bit further. Barring arithmetic mistakes, I got negative x cubed plus 5x squared plus 17x minus 33.